Silence of Water, Taphonomy, and the Missing Sabungeros. Richard Jonathan O. Taduran, Ph.D. Taphonomy is the study of what happens to the body after death, but in forensic science it is also the study of silence, the silence of time, of chemistry, of concealment, and sometimes the silence of water. That silence resurfaced in chilling form when reports emerged that some of the missing Sabungeros who vanished between 2021 and 2022 had been murdered and dumped into Taal Lake. With that revelation, forensic science was drawn into a new kind of terrain: deep water, long timelines, volcanic chemistry, and a case that had defied resolution for years. As a biological and forensic anthropologist, I've spent much of my career studying taphonomy, skeletal biology, and crime scene interpretation, first in the UK, then in Australia. My work took me to forensic missions in Europe, South America, and the Middle East, and into environments ranging from controlled laboratories to complex outdoor and aquatic sites. But I always knew I would return to the Philippines, not only to teach, but to help build the forensic science infrastructure our country urgently needs. That commitment has guided me ever since. In cases like this, taphonomy becomes the cornerstone of the investigation. When bodies are reduced to their barest elements, decomposition becomes the language we must read. It's where science meets silence, and insists on speaking anyway. Concealed in caldera. Taal Lake is no ordinary body of water. Formed within a volcanic caldera, it reaches depths of nearly 200 meters and contains volcanic minerals like sulfur and iron. Its relatively still, tropical waters and anoxic zones make it both a preserver and a concealer, delaying decomposition in some areas while accelerating it in others. From a forensic standpoint, this makes recovery and interpretation especially complex. At the time of writing, sacks containing suspected human remains have been recovered, and further underwater operations are underway. The postmortem submersion interval, PMSI, is estimated at 3.5 to 4 years, which means full skeletalization is likely. Though some adipocere, also known as grave wax, a waxy substance formed when body fat breaks down in moist, low-oxygen environments, may still be possible in deep sealed conditions. Based on my almost 2 decades of experience in forensic anthropology, including cases involving marine environments, I know that water chemistry affects staining, preservation, and even DNA viability, and that depth and temperature influence microbial activity and tissue loss. Given the unique characteristics of Taal Lake, these are the taphonomic alterations that may be expected. Abrasion, prolonged contact with sediments or movement within the water column can cause bones to become rounded and abraded, especially in areas with underwater currents or coarse particles. Sediment embedding, volcanic ash and fine sediment may infiltrate bone cavities and adhere to surfaces, leaving residues that complicate cleaning and analysis. Staining. Bones may exhibit reddish hues from iron oxides, black or dark staining from sulfur compounds, and green patches from algae exposure, direct reflections of the lake's mineral-rich composition. Biota. Freshwater fish and crabs in Taal Lake may cause minimal soft tissue disturbance, but grazing marks on bone surfaces are still possible depending on the level of exposure and decomposition. Disarticulation. In unconfined remains, smaller skeletal elements, e.g., hands, feet, ribs, are often the first to detach. However, the reported use of sacks or tie wires, if verified, would have preserved articulation, increasing the likelihood of recovering intact or partially connected skeletons. Burned bone. As suggested in this case, fire damage introduces thermal alterations that complicate trauma analysis, but diagnostic features often remain, such as fracture patterns, color changes, and shrinkage, that still provide valuable forensic insights. These are not just scientific curiosities, they are evidentiary tools. Taphonomic patterns can tell us if a body was burned before or after death, if it was dismembered, how it was disposed of, and whether it was moved. In the absence of soft tissue or reliable DNA, taphonomy becomes the map, and bone becomes the voice. The role of forensic anthropology. To recover and interpret human remains from an environment like Taal Lake requires more than courage and equipment. It requires forensic anthropology. Taphonomy may explain how a body decomposes, but it is the forensic anthropologist who translates that process into information that can be used in court. From estimating time since death to identifying trauma patterns on burned or submerged bone, anthropology becomes the interpretive lens through which taphonomic clues are read. In the Philippines, however, this expertise remains under-recognized, underutilized, and often misunderstood. While the need for forensic recovery has grown through disappearances, disasters, and criminal concealment, the professional infrastructure has not kept pace. Skeletal remains are frequently handled by those without specialized training or, in some cases, simply left unidentified. Positions that require anthropological skill sets are often reserved for medical doctors, even when the task calls for osteological, archaeological, or taphonomic expertise. This case reveals the consequences of that gap. We are operating in one of Southeast Asia's most complex aquatic environments, with a high-profile criminal case gripping the nation. Now is the time to recognize the necessity of forensic anthropology and to invest in specialized training to strengthen our investigative capacity. The stakes of scientific recovery. The challenge now is not only to recover the remains, but to recover their meaning. This requires a multidisciplinary approach. Sonar scans, remote-operated vehicles, divers trained in forensic recovery, and experts who understand what 4 years in a volcanic lake will do to a human body. We need scientists who can read what remains. It also requires humility. Not every bone will speak, not every body will be identified, but each recovery affirms that science is still looking, that justice has not let go. Taphonomy, in this case, is not just about what decomposes, it is about what survives, despite time, water, and the intent to disappear someone forever. The missing Sabungeros case is, in many ways, a test of the Philippines' forensic capacity. It shows how far we've come in understanding death and concealment, and how far we still have to go. It highlights the urgent need for local taphonomic data and formal inclusion of forensic anthropologists in death investigation teams. What happens after death is not just biology, it is context, and the more we understand that, the more truth we can recover, one submerged silence at a time.